I would like to go through one problem related to the test of hypothesis and try to come up with a solution for it. And the very first thing I'll do when I'm dealing with a problem related to the test of hypothesis is to read the problem carefully and determine if it's dealing with one population, two population, or more than two population. Now, when I'm reading problem 9.28, clearly I can figure out that dealing with one population because I am taking a sample from one population. Then the second thing is I need to determine is it related to um, mean of population or it's related to the proportion of a population. Again, here I read the problem and I can see here that I am dealing with the average or the mean because the problem is asking me to determine if there is a difference, evidence that there is the mean amount spent for lunch is different from $6.50. So right now I know I'm dealing with the MENA population. So the next thing is to try to determine what kind of test I need to use. As long as I have a small sample, by small sample I mean n is less than 30 samples, my sample size is less than 30, then I tend to use a t-test. Furthermore, your book actually uses standard deviation also and see if population standard deviation is unknown. At that time, we need to use a t-test or try to use a small sample test. So here, right now, I know eventually I need to go through the t-test. And now, and to do this, I'll try to use Excel and try to do some calculation using Excel. So I'm going to try to activate Excel. And I already stored data in Excel. And so let me try to go to um, Data tab and see if the data analysis is active. As long as the data analysis is active, it means that I can use this to try to determine what's the uh, sample mean and what's the sample standard deviation. So let me activate that. I'm going to go to descriptive statistic and try to see what I need. Here it's asking me for the input range. My input range is here. And since I have the title of a column in the first row, I'm gonna make sure I mark this one because label is in the first row. And then I want to say the result to be right in front of me, put it in E1, column E row 1. And lastly, I want to ask for summary statistic. So as long as I haven't made any mistake, I should be able to get the information. And now it goes through and basically comes up with the sample mean. And that's obviously it's my sample mean. It's roughly, if I round it up, it's roughly is 7.1. And then my sample standard deviation, it is roughly one, my sample standard deviation is 1.41. So I'm just rounding it up again. And now let me go to PowerPoint. And as I said, I already decided since the sample size is small, I'm going to use a t-test. And the t-test I am going to use, it's going to be known as T of observe or T of start. I need a sample mean minus mean of population under my hypothesis over standard deviation S, uh, the whole thing under square root of n. So the next thing I need to do, I need to set up my hypothesis. Again, the best way to figure out what to do is to go back to the problem and see what the problem is asking. The problem is asking me basically at the 0.05 level of significance, is there evidence that the mean amount spent for lunch is different? The keyword is different from 6.5. So Right now, since I am dealing with the difference from 6.5, my alternative hypothesis should be not equal, not equal to 6.5. It could be less or it could be more. So I'll try to set up my hypothesis. Let me go to the PowerPoint. And the very first thing I do, under HO, always I try to have it as equal. Mean is equal to 6.5 mu. And versus my alternative, mean is not equal to 6.5. And remember, I did find this by reading the problem. When the problem is asking the mean is different from 6.5, that means your alternative should be not equal. Some other problem they might ask if the mean has changed. Again, that would be two-tailed test because my alternative would be not equal to. So now I'm going through the problem. The problem is telling me that alpha level of significance is 0.05. So as long as my alternative is not equal, it means I have to divide alpha by 2. So I'm dividing alpha by 2. Now I go further through the problem and I find out that the sample size is 15, n is 15. So my degree of freedom is going to be n minus 1, which is 15 minus 1, it's going to be 14. And obviously my statistical test is based on t-test, and this is a formula I have for it. Now, using Excel, I found out my sample mean is 7.1. Let me go back to Excel. That's my sample mean. And my sample standard deviation, eventually I rounded up to be roughly 1.41. So I have that one. And if I go back to PowerPoint, you see I need to plot X bar as 7.1 and sample standard deviation S as 1.4. Now, my population mean is 6.5, the value of mean under HO. And lastly, my sample size is N, which is 15. So if I go through this calculation, it's going to roughly give me 1.65. This is my statistical test value. Now I have to go to table. And basically based on what I have with 14 degrees of freedom and my alpha, since I divided by 2, would be 0.05 divided by 2, it would be 0.025. Now I'm going to go and see with 14 degrees of freedom and 0.025 what will be the corresponding t-value. It is 2.145. So that's my T of table. So if I go back to PowerPoint, I can construct my rejection region. Any T less than minus 2.145, it's going to be my rejection region to the left. And any T is more than 2.145 would be in my rejection region on the right side. So I have two rejection regions, one on the right and one on the left. Now I'm going to compare my statistical test value, which is actually here, I should have it as 1.65, compare it. And obviously 1.65 is in non-rejection region, not reject HO. So my decision would be do not reject HO. And my conclusion would be insufficient evidence that the true mean lunch expense is different from 6.5. So what I am really saying is that my statistical test failed to reject HO. Now, there are a couple of other issues I think it was worth mentioning. Sometimes we have what is known as a one-tail test. And that would be the time that alternative hypothesis focus on a particular direction. I know your book always likes to use it this way, but I usually try to make it easier by just saying that under HO, I always have equality. And we say, okay, let me read the problem carefully and see what the problem is asking me. If a particular problem asks me to determine if its mean of a population is less than certain amount or it has been reduced, then right away I know my alternative should be less than. On the other hand, there are some other problems they ask for a different kind of alternative. They might ask if the mean of a certain process is more than particular value. More than, it means greater. And if they may say something, if the mean has increased, then again, your alternative would be this. So here, what I am really doing is under HO, always I have mean is equal to particular value. Under alternative, I read the problem very carefully, and depending on what the problem is asking me, I determine my alternative. Now, eventually, this will tell me when I go to the table what if I have to go to the left tail or right tail. Right now, if somehow we assume that my alternative is this, is less than, then when I go to the table, eventually I'm gonna use left tail. Make this also equal again. Now I'm going to the left tail, and my alternative would be uh, less than, and my rejection would be to the left. Remember, I'm not dividing alpha by 2 here. I'm just staying with what I have. Only thing when I go to the T of table, I have to, or Z of table, then I have to have a minus T of table there. On the other hand, if my alternative is more than, like this one, then I'm going to end up going to the right tail. Now, again, I'm going to make these as 6.5. So now my rejection region would be to the right. And when I go to the table, Z table or T table doesn't matter. Eventually, my alternative would be to the, my rejection region would be to the right. And if my statistical test value is more than T of table, I would reject. Um, if you have any question, please let me know. This is kind of confusing one, deciding about two tail or one tail, and also deciding about what kind of test to use, Z test or T test. I think to make it simple, usually I deviate from your book to make it a little easier. Usually, always I write down HO under HO, null hypothesis. I always write down equality. And also, when it comes to uh, going to right tail or left tail, I just look at my alternative and right away I go there. Um, Thank you for watching.